Hello, Year 9. Your first job, make sure you've got something to write with, something to write on, so pen and paper. Get yourself a clock, a timer, or a song that you like that lasts about 5 minutes, because that's the time for your first little task. Okay, so pause the video until you've got those. So, this week, my hay fever has been absolutely shocking. It's been really, really bad. Okay, so I thought we'd do something to do with hay fever, but from a physics point of view. So, this chap, okay, Charles Blackley, he was the first person to link pollen and the symptoms of hay fever. Okay, and one of the solutions he had for getting rid of his hay fever was go to the beach. I want you to describe what's happening in here in terms of convection and the particles and energy transfers and heating. I want you to describe what's happening in this convection current and therefore describe why, if I went to the beach, my hay fever wouldn't be quite so bad. Okay, you're going to have to include a sketch diagram. Okay, at least one. Okay, it might be that your explanation is just pictures described. It should be actually really good. I haven't done that. Maybe I should have. Whatever. You've got 5 minutes. I want you to describe that picture. I want you to describe what's happening in terms of particles and convection currents. Okay, so pause the video here and start your time and see how you get on. Okay, so hopefully you've now finished your 5 minutes and you've got that description of convection currents. Here is mine. So, underneath my picture we've got, so the particles over the warm land, okay, they gain heat energy, so the temperature gets bigger. They've got a higher temperature here. Therefore, the particles are moving around faster. And if the particles are moving around faster, they're taking up more space, so the density of the gas decreases. It's got less dense. And if it's got less dense, it rises. Okay? And then it can carry on going around. So that's where I finished my little description, but it carries on going around. As it's moving around in this cycle, it starts to lose heat energy. Okay? Therefore, the temperature drops. The particles are moving slower. If the particles are moving slower, they will take up less space. So the gas becomes more dense and therefore sinks. And it sets up this convection current. Okay? And then linking to the pollen, there's no plants producing pollen over the sea. So the amount of pollen in the cool air that's coming from the water is much, much less than it would be from inland over here. Okay? Now, you could have answered your question, like I said in the little description, where you've drawn particles. So you draw the particles in the gas here, and you can show them heating up, so they're moving around really quick, so they take up a large area, a large volume, so the gas becomes less dense, and they rise. Now, notice I'm being really careful in my description. Okay, I'm saying that the particles gain heat energy. The particles, therefore, are moving quicker. So the particles take up more space. So the gas, not the particles, the gas becomes less dense, therefore rises. Because you need to be really careful in answering this question if it comes up on an exam. You do not want to make the examiner think that you think that the particles change size. The particles do not change size. The space between them changes, but the particles themselves do not change size. Okay, and you don't want to try and write that. So if in your answer you've got anywhere where it says the particles change size, give a little cross, okay, and correct it and say the particles don't change size. Write it in big and put a box in half highlighter around it and underline it and make it really important. Okay, now this week we're going to do some exam questions on hydroelectricity, on wave generation, and on tidal power. Okay, we're going to do them slightly differently to how we've done them before. I'm going to have the link with the questions and the mark schemes in class charts, but I'm going to go through the questions as well. I'm not going to just tell you the answers, but I'm going to tell you my thought process, how I would go about answering them. So you can either do the questions, then look at the rest of the video, or you can do the questions while I'm talking about it and pausing it while you're filling in answers and then marking it. Or you could watch the whole video and then you can go away and do the questions. I think I'd probably do it the second way. Don't know. Well, here we go. So I'm going to pause my video. Okay, so this first question, I just want to point out that in an exam, whenever they give you some information here, it's not just to trick you and take up space in the paper so the paper looks longer. It's there to help. It's there for a reason. Okay, so you've got a pie chart, and the question says, which 2 energy sources used by the company does not produce any polluting gases? So you've got to pick one of those 4. Okay, you can't just pick an energy source that doesn't produce any polluting gases. So I couldn't pick, for instance, nuclear. I couldn't pick nuclear as an energy resource because it's not in the pie chart. The company doesn't make it. So you've got to pick the 2 that make sense. Okay, and you've got to pick the 2 that are renewable. Okay, here, the solar and the wind. Coal and gas both produce carbon dioxide. Then you need to calculate the percentage. So you need to take your 2 energy types and you need to add the percentages together. Now here is a really good example of error carried forward marks. So let's say that for whatever reason you didn't get these 2 right. Let's say you wrote solar and coal. Okay, it might have been a harder question, you got these 2 bits wrong. So you wrote down solar and you wrote down coal here. Even though it's wrong, you can still get this mark if you follow through. Okay, so if you just add together the 2 percentages from these 2, you'll get the mark here. Solar plus coal, so that would be 33%. If I wrote 33% and I'd written coal and solar here, I'd get this mark even though this is wrong. You get error carried forward marks. Okay, and in the mark scheme it should have here ECF, correctly added as error carried forward. Okay, so just be aware that it's always worth giving a question a go. This bottom one, we've got graphs and we've got to tick the right box. We've got to think which is the most likely one from wind. Okay, what do we know about wind? It's not the same all the time, so it can't be B, because the amount of wind I get will change. But it doesn't change beautifully smoothly over this time of day. Okay, it doesn't change like that. It doesn't. So it's got to be this A. It's got to be A. So the power output for A shows that it's fluctuating. It's getting stronger and it's getting weaker at different times. Okay, think about what kind of power resources these might produce. Okay, the answers are up here. And then government has said that more electricity must be generated from renewable sources and used for forward. More wind farms, solar generators and gas burning power stations need to be built. What's wrong with that statement? Why is it wrong? What's wrong with it? You need to write down the answer. 2. We've got another pie chart. Okay, so we've got renewable, nuclear, gas and coal. Calculate the percentage of electricity generated using fossil fuels. So this one, you're identifying which are fossil fuels, okay, and then adding them together. Okay, coal and gas, add it together. The pie chart shows that 7% of electricity was generated using renewable energy sources. Which of the following is not renewable? So this is just recall, knowing which is renewable, which is not. Okay, is it oil, solar or wind? Complete the following sentence. In some types of power station, fossil fuels are burned to heat something to produce steam. So heat what? What do we heat inside a power station? Okay, let me just... Good clue. Burning fossil fuels releases carbon dioxide into the atmosphere. Why do many scientists think that adding carbon dioxide to the atmosphere is harmful to the environment? So which of these is the most relevant? Carbon dioxide is the main cause of acid rain. Carbon dioxide causes global warming. Carbon dioxide causes visual pollution. Carbon dioxide it's not the main cause of acid rain. Okay, those would be sulfur oxides and nitrogen oxides. Okay, carbon dioxide is invisible, you can't see it. It's not there, you can't see it. Okay, so it won't cause visual pollution. But it does cause, it is linked to global warming. Right, 3. Oh, this is a good question. I love this diagram, it's brilliant. Okay, diagram shows a small scale micro hydroelectricity generator which uses the energy of falling river water to generate electricity. So we've got this river and it flows down here and it's got this like a screw and it spins. This whole thing spins around. And it's linked to a generator and it generates electricity. Complete the following sentence by drawing a ring around the box. Okay, gravitational potential energy up high is transformed into, it should be better to say transferred, into the something energy of the Archimedean screw. So it spins, it's moving, so it's got to be kinetic. The micro hydroelectricity system generates about 60 kilowatts of electricity, enough for 50 homes. Okay, hydroelectricity, 500,000 kilowatts. Give one advantage of conventional large-scale hydroelectricity compared to micro. Okay, so you've got to use the information up here. Okay, small, 50 homes. Big, 5 million home. You can generate more electricity. This one you've got to tick the right box. Which of the following statements gives a disadvantage of conventional large-scale hydroelectricity power? Energy is wasted as heat and sound. Large areas of land are flooded. Constant flow of water is needed. Electricity generated by micro hydroelectricity system is transferred directly into local homes. Blah, 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 blah. What name is given to the system of cables? Transformers used to transfer electricity to homes. There's another bit of recall that you need to know. Okay, the national something. The national grid. Using short cables to transfer electricity to local homes is much more efficient than using very long cables to transfer electricity to homes everywhere in the country. Why? Whenever you get energy transfer, something happens. Some energy is wasted. If you use short cables, less energy will be wasted as heat. Nepal is a mountainous country with 6,000 rivers. In Nepal, 9,000 kilowatts of electricity are generated using micro hydroelectric generator. Suggest one reason why the UK is much less electricity using micro hydroelectric generators than in Nepal. So what's the difference? Why does it give you this statement at the beginning? Why is it said that there's 6,000 rivers? Why is it giving you that bit of information? Okay, we don't have as many rivers. We don't have as many mountains. So the chances of us using hydroelectric, those tiny little generators, is much smaller. Okay, tidal barrage. Oh, good question, this one. So this one is a calculation question. This is tricksy. Okay, in 1 second, I'm running out of time on my video, 1.2 times 10 to the 9 kilograms, so a very big number, okay, of water flows through the turbine at a speed of 20 meters per second. When used with water speed of 20 meters per second, the system has an efficiency of 90% in converting the kinetic energy of water into electrical energy. Calculate the power output of the generators. Okay, so you need to figure out how much energy is coming out. What do we need to know? Think about this. Think about kinetic energy. We're given a mass, we're given a speed, and we're given kinetic energy. This is a really harsh 2 marks, because you also need to then give the answer as 90% of that number. So you need to work out the kinetic energy using this number, and then find the percentage of it. Okay? The power output of a coal-fired power station is 1,000 megawatts, 1 times 10 to the 9 watts. So just 2 advantages of coal power stations over tidal. So you've got 1. Compare it with the amount of energy. I would imagine that the coal is going to produce more energy. 2, okay, cheaper. Okay, doesn't impact rivers. So just 2 advantages of using tidal. It's renewable. It does not give out greenhouse gases. So just 1 disadvantage of tidal. Suggest and explain 1 disadvantage of a tidal generating system. You're only going to get a certain amount during the day. There's going to be peaks and troughs in terms of, well, that's a 6-mark question. That's only got 3 lines. This is tough. This is a difficult question, actually. So you need to come up with one clear disadvantage. I don't think this should be a 6-mark question. This is not a great question, but there we go. One clear disadvantage of that tidal generating system. Okay, explained with detail. This is a longer written answer. Okay. Now I hope me talking about some of the questions has helped a little bit in filling them out. I hope you have a good week. I hope you're doing well at home. Take care and goodbye.